All right, so warm-up 48 should be on your screen. It shouldn't take you longer than 5 minutes. 5 minutes. Every given 1, 9, 6, 9, 7, 7, 5, 1, 4, 10, and 15. Compute the measure central tendency and sketch a box plot. Give you guys 5 minutes. All right, thank you. Let's see, check your work up on the screen. The mean, who got 6.7 approximately? Yes, median 7. Mode 1, 7, and 9. The box plot, minimum is 1, maximum is 15, Q1 is 4, Q2 is 7, Q3 is 9. All right? Copy the agenda, please. Warm-up 48 done. Measures of variation, we're in the middle of that. Today we're going to have independent practice due at the end of the period. I'm trying to scoot this up as expeditiously as possible. And tonight, study. Let's go. Oh, that's a good idea. Jacob for Presidente. What? Oh my God. Yeah. Okay, we good? Once again, warm-up 48 done, measure of variation, independent practice today, and tonight study only. So for today, I'm not giving you any code because you know how to study. And last night's home plate were the evens, 2, 4, 6, and 8. Those, they're a gift from me to you. It was practice. Woo. Let's go. All right. So, with that said, get a Cornell note ready, please. I can summarize data and compute measures of variation. I can summarize data and compute measures of variation. Today, I'm just going to add a couple more things to some of those formulas, just so that it's a very small issue. But other than that, you guys should be experts at all this, yeah? All right. Copy the objective, please. All right, here we go. Measures of variation. We're in the middle of that. Look up. So, without looking at your notes, tell your neighbor the 3 different measures we're going to cover for the next sessions. Without looking at your notes. All right, let me send that to your screen. Fill up the diagram on your screen, please. Do that right now. Focus, focus, focus. We've only covered 2 different measures. We're headed on the last one, but by now you should know what they are. Variance, that is correct. So central tendency, our mean, median, and mode. Variation, our range. Variance, and standard deviation. All right. Let's see how well we do with our formulas. Look up on the screen. Without looking at your notes, fill in the formulas for those. It's only 9 of them. My bad, 11 of them. Without looking at your notes. Focus, please. Once again, without looking at your notes. 7, 6, 5, 4, 3, 2, 1. All right, there they are. All right. So look at them and make a note as to what you need to study for tonight. So make sure you get some index cards ready or something, so like that you know each of the formulas. All right, so with that said, here we go. So yesterday we reiterated that the variance and standard deviation for population and sample are the same. Does everybody agree with that? But there were only three differences. Is that correct? All right, remind your neighbor the three differences from one to the other. What are they? All right. Looks like Moses got this one, but let's go with Isaiah. Isaiah, what are the three differences from one to the other? Let me zoom in. The N, that's one. The S and the sigma, that is correct. The mu for mean population, and X bar for mean of the sample. Hands if you see that, yes? But pretty much it's the same formula, is that correct? This is for variance, and this is for standard deviation. Now, what's the difference from one to the other? Well, this one is the number before we do the square root and get our standard deviation. Okay? Today, we are going to make a little change on one of them. Look up to the screen. And why is that, Mr. Q? Because if we leave it as is, then the same answer is going to give us for a smaller amount of numbers than a larger amount of numbers. But we know that in statistics, the more numbers we have, the cleaner the statistic will come out. So, check this out. So yesterday we did this one. We went through the entire process and we saw where we got the formulas from. There it is. Today, I want to reiterate these on number 6 that you did last night. Look up. So it says here that the three data sets have the same mean and range. Okay? But it says, but is the variation the same? So what are they asking for the variation for all three of them? It says, assume the data were obtained by samples. So which formula would I use? The one for samples, is that correct? So there they are. Do you agree we're using those? Yes? Okay. Tell your neighbor why, because some people still don't understand why we're using those. All right, why are we using those? Isaiah, pass them one. Sam, why are we using those formulas? Yes, he said because since they're asking for samples, we're using the ones with the letter S for sample. Does everybody see that now? All right, so I'm going to make a small change today because for sample data is any number from 30 data and below, because we're about to get into big numbers which are 30 and above. Any numbers 30 and below should give us a different standard deviation and variance than numbers greater than that. Why? Because the more numbers we have, the cleaner the data that we get. So there's something that we're going to add to this formula. Look up or you're going to miss it. Here it goes. Here it goes again in case you missed it. Here it goes again. So here what we added to that formula. So at the denominator, instead of just dividing by the number of numbers, we're going to divide by the number of numbers minus 1. So that in statistics is what we call the unbiased estimator. What is it called? Unbiased estimator. So go to your formulas in the back, make that change and label that, please. Label it unbiased estimator. And why do we do that once again? So that we don't use the same formula as the bigger population statistics and variance, standard deviation and variance, and have a biased answer to our data. All right, so on your formula, you just should have added a -1 on the denominator for the n, and you label that what? Unbiased estimator. And why do we use that? So that it gives us a cleaner data when we find the mean, the standard deviation and the variance for sample compared to population. All right, so let's go back to our notes. Look up. So this is saying that all three of these data, look up, have the same mean and range. Sure they are. Does everybody see that? Yes? All three of them have the same mean and same range. So, in order for us to find standard deviation and variance, I'm going to compute the first one. Some of you already did that yesterday. Here are those numbers. The variance for A was 18.6. Standard deviation is 4.32. For Part B, those of you that did Part B, variance was 25.6. Standard deviation 5.06. And the last one, variance was 36. Standard deviation is 6. So, today, what I'm showing you here with the three different data is showing you how to compare those data. How do you compare it, Mr. Q? Well, if the data have the same mean, do they all have the same mean? Yes, Mr. Q, because it says over here, assume that they have the same mean. Then you just go by the variance or standard deviation and see which one has the most variability, which one's more variable. So by looking at them, which one has the highest standard deviation? It would be part what? C. That one is the most variable. The most variable of the three. Which one is the least variable? Part A, because it has the smallest standard deviation. Once again, if I ask you for the most variable, tell your neighbor what to do, please. And how do you know? Because you're going to be doing one right now, and it's due at the end of the period. I'm just trying to get this through with you. Tell your neighbor how you know which is the most variable. All right, Sam, pass someone. Highest standard deviation. Hands if you agree with that. That is correct. That's the most variable. So, with that said, get into teams of two. Tell your neighbor who's doing A and who's doing B. Who's doing A, who's doing B. All right? You ready? Who's got A? Let's see. I want to see hands. A. Who's got A? A. Okay. There it goes. And those of you doing B, there it is. And the question is, which one is the most variable of the two data that you are given? Yes, I'll send it to your screen. This is due at the end of the period. However, I am going to be calling you so I can see your work as we do this process. Those of you following on YouTube, make sure you put some work in. See you guys next time. Peace.